The second measure of center, and this is used even more often than the median, is the mean, which is just the average that you have been using your whole life. So basically, the mean, it has a symbol, it's Y bar, there's a bar over the Y. And so we kind of think of the values of your data set to be Y's, all right? So remember, you had like Y1, the first mileage was 47,000 miles. And then Y2 was 65,000 miles. All the way up to we got Y20, that was 180,000 miles. So the mean is I'm going to add up all 20 values and then divide by 20. All right, so n is 20, that's the sample size. This little symbol next to these yi's is a capital sigma, and sigma, this means the sum of. So I'm going to sum up all the y's and divide by n. So I'm going to, y1 plus y2 all the way to yn over n. So for this particular data set, if I was going to calculate the mean, I would take it and I would say, okay, the first mileage was 47, and then the next one was 65, and then I would add the next one until I got to the very last one, which was 180,000 miles. And then I would divide that all by 20. And this happens to be equal to 1,871 if I added up all the 20 mileages, divide by 20. And this gives me 93.55 thousand miles, which is about 10,000 more miles than the median. The median was 83,500 miles. Now here is a property of the mean. Where the median was not influenced or was resistant to outliers, the mean is highly influenced by outliers. And so what this means is if I have an extreme outlier, especially, if I have an outlier, if I remove it, for instance, if it was an extremely high outlier. So if I remove an extremely high outlier, what's going to happen is now my values are going to be a little bit lower than they were before. And so if I remove an extremely high outlier, the median, what I meant to say here was the mean will go down. Will go down. And it can go down a lot. Now above, when we remove the biggest one, if we remove this 180,000 miles, and it's a little bit bigger than the rest of them. So if I said, okay, here's going to be, let's call it Y bar, little r, remove one value, okay? Then this, now I'm gonna add up everything except the very last one. The second to the last value was 141,000 miles. And I divide by 19. This is actually equal to 89,000 miles. So it dropped about 5,000 miles. So we don't want to use the mean for extremely skewed data. All right, so then the question comes, when to use the median, when to use the mean. So again, the median is a better measure of center. These are both measures of center. The middle, all right, is a better measure for center. Get rid of that, and, okay, for very skewed data. This is a repeat, or data with extreme outliers. otherwise, we're going to want to use the mean. So otherwise, the mean is a better measure of center for data that is not extremely skewed, not without extreme outliers. So this would be, so we're going to use this for symmetric data. Or if it's just moderately skewed. So again, mileage, we take a look at mileage, this graph. All right, it's slightly skewed. It's a little bit skewed right. It's not extremely skewed right. So we could use either of these centers. But here's the deal. The mean has some really, really good properties that we're going to talk about later. So for that data, I would probably report the mean. This data is, if I was going to describe this data set, I would say this is unimodal. All right, this is not slightly skewed. I mean, but there is no left tail. All right, so the mode is here. There's no left tail. It's all right tail. All of that. That's on the entire thing. So this is very skewed right. And I don't know if I would call this an extreme outlier. It's got a gap of 2 bins, but it has a high outlier. For data like this, I want to use the median. The mean is not going to be a very good measure of center for that data.